In this video, I will talk about kinematics in two dimensions, which is basically the motion of a projectile. Let's say a boy stands on a high-rise building of height h. Okay, now let's say this is the boy. If this boy throws a bread, let's say he has a bread in his hand. By throwing this bread horizontally, let's say he threw this bread horizontally that means the bread will be moving at an horizontal velocity. Let's say that is u. Notice that it is an horizontal velocity because it didn't throw this bread upwards vertically. So because it's an horizontal velocity, the u in this case will become ux. Notice that velocity is a vector quantity, and then the uy will be equal to 0. As this object moves horizontally, it will also fall downwards. It will also fall downwards in this direction. Now, the distance, let's say the distance between the bottom of the high-rise building and then where the object lands, let's say it is r, which is referred to as range. The range r is the distance traveled by an object on the horizontal plane. Notice that as this object falls downward, the object falls downward in this manner, and it also moves forward. It falls downward due to gravity. As a result, the gravity acting on it is positive. Let's say the vertical distance at which the object falls, let's say it is h. That is, we can refer to it as sy instead of ordinary s. And then we can refer to the vertical distance, which is r. The horizontal distance, which is r. H is the vertical. We can refer to that as the sx. Okay, now suppose that you have a question that says you should find the height of throw or the vertical distance at which the object will travel. Now recall that the equations of motion xs, which is equal to ut plus half at squared. Since we want to find the h, remember that is the distance of the object on the vertical plane. So we'll consider the vertical planes. So the vertical planes now, it means that we have sy, we are considering the vertical planes, uy, then we should have ty, but t is a scalar quantity. It does not consider directions, so it does not consider components, whether tx or ty. T still remains as t plus half. Half is also a constant. Now a will become ay because acceleration is a vector quantity. Now notice that ay is acceleration due to gravity because that's the acceleration it uses to move downward. So we can have ay to be plus g, and then ax, notice that ax is equal to 0 because the acceleration due to gravity does not act on the horizontal plane. It only acts on the vertical plane. It is one dimensional. Uy is also equal to 0. That is, the object was thrown horizontally, not vertically upward. So uy becomes 0. So that sy is equal to half. Ay is now g, so that sy becomes half gt squared. Notice that sy is the same thing as h. As a result, the h, which is the distance of the object on the vertical plane or the height of the building, is half gt squared. So this is the formula to find the height of the building or the vertical movement of the object. Notice that we can find the time if we multiply through this equation by 2, then we'll have 2h equal to gt squared. Then divide both sides by g so that we'll make t the subject of the formula. As a result, t squared becomes 2h upon g, so that t is equal to the root of 2h upon g. So this is the time taken for the ball to reach the ground. Okay, let's say this is equation 2. Notice that we can also find the horizontal distance of the object. Okay, now that means we'll consider the horizontal plane, that's sx, which is equal to uxt plus half axt squared. Now notice that ux is the same thing as u, which is u, then we are going to have u multiplied by t plus half remains half. Ax is 0, so that we'll have t squared. It implies that sx is actually ut. Notice that sx is the range, so that the range r is equal to ut, where u, don't forget that u is the horizontal velocity. So this is the formula to find the range of the object. Let's say this is equation 3. Notice that I can substitute time into equation 3, so that equation 3 will become r equal to u. Instead of t, then I will have 2h upon g. So we can make use of this formula. If the time is not known, the height is known, the acceleration due to gravity is known, and the initial velocity is known, in order to find the range. A bomber is flying at a constant horizontal velocity of 1000 meters per second at an acceleration of 2.5 km towards a point directly above its target. At what time would the bomb reach the target? What is the horizontal distance traveled by the bomb? At what angle of sight shall the bomb be released to strike the target, neglecting air resistance? Now, let's say this is the horizontal ground, and then this is the bomber. All right, the bomber is moving horizontally at a particular initial velocity ux, which is equal to 1000 meters per second. Now, at an elevation of 2.5 kilometers, that means the distance from its from the position of the bomber to the ground, that's the elevation, it is 2.5 kilometers. So 2.5 kilometers from the ground. Okay, towards a point, it moves towards a point that is directly above its target. Of course, let's say it is moving towards this point, and of course this point is directly above towards its target. Okay, at what time would the bomb reach the target? Let's say this is the target, this is the target, and then if it releases a bomb, if this bomber releases a bomb, let's say it releases a bomb from this point, if it releases the bomb will move horizontally, and then it will fall, it will move this way, and then it will fall vertically downwards, targeting the bomb. All right, so it has an horizontal velocity, and then but then it falls to the ground as well. So it is the same scenario that occurs. All right, where this is the range, and then this is the height, which is the same thing as the elevation. Now the question says, at what time would the bomb reach the target? The time at which the bomb will reach the target, we have found that the time is 2h upon g, which is equal to the root of 2 multiplied by the height. The height in this case is the elevation. So we can find the elevation, which is 2.5 kilo, that's 1000, okay, upon g, which is given as 10. So we can 2 times 2.5 multiplied by 1000 is 5000, then divided by 10, that's 500. So the square root of 500 will become 10 root 5, which is 22.36. That's 22.36 seconds. All right. In order to find the horizontal distance traveled, notice that the horizontal distance traveled is r, which is the range, and that's of course equal to ux multiplied by t, where ux is 1000, then the time is 22.36, and that's supposed to be equal to 22.36. In order to find the angle of sight at which the bomb be released to strike the target. That angle of sight will be this. This is the horizontal movement. This will be the angle of sight. Then this will be the angle of the sight, angle theta, because this is the direction of the target. And of course, this is the angle at which the target will be sighted. So this angle, if this is theta, then this has to be theta also. They are alternate angles. Alternate angles are like this. Okay, so we can, of course, we know that the range is now 22360 meters, and this is 22.5 kilometer, which is the same thing as 2500. Okay, so we can find angle theta from that, since we have the opposites and then we have the adjacent. And of course, from SOHCAHTOA, opposite tan, that means we'll make use of tan theta, which is opposite, and that's 2500 upon the adjacent, which is 22360. So if we divide, that's equal to 0.1118. So that theta will become the arctan of 0.1118. The arctan of 0.118 is 6.38 degrees. All right, so the angle of sight is 6.38 degrees. Let's say an object is thrown upwards at an angle theta to the horizontal axis. Okay, notice that the object will move in this direction. Okay, where this point to this point is the maximum height reached by the object and is referred to as the H max. This point to this point is the range, that is the distance of the object on the horizontal plane. Alright, notice that the angle theta is towards the x-axis. Okay, now the initial velocity of the object, let's call it u. Now notice that as the object approaches upward direction, it also approaches the right direction, and then when it gets to this point, it moves forward, but it returns to the ground due to acceleration, due to gravity. It returns to the ground and then it moves forward. So we can bring out the velocity. The velocity that acts in this case is the uy, and the velocity that acts in this case is the ux, that pushes it forward. The uy pushes it upward. So we can have the component of the velocity in this case as ux and then as uy. So the magnitude of the velocity, we can find it, which will be the resultant velocity, which is u. And then to find the magnitude, then we need to make use of the Pythagorean formula, where this is ux and this y-axis will be uy, and then the hypotenuse will be u. So that from the Pythagorean formula, which is u squared, that is hypotenuse square, is equal to the square of the sum of the both other sides. Okay, so we have uy squared plus the ux squared. Then the magnitude of the velocity is the square root of uy squared plus ux squared. Notice that uy and ux, it is at a particular angle theta. So the implication is that I can resolve u into ux. To resolve u into ux, since there is an angle here, that means ux will be equal to u cos theta. That is, I can find it using the cosine rule. That is, the cosine of cos is adjacent upon the hypotenuse. The adjacent in this case is ux, the hypotenuse is u, so that ux becomes u cos theta. So the same thing, the sine of theta is uy, which is the opposite upon the hypotenuse u, so that uy becomes u sine theta. So to find ux, the formula for ux is u cos theta, and the formula for uy is u sine theta, and the magnitude of this of the velocity is the root of uy squared plus ux squared. In order to find the time at which the object would take to reach the maximum height, let's represent that with small letter t is equal to u sine theta upon g, then the overall time taken by the object, which is capital letter T, which is the same thing as the time of flight or the time spent on air. The total time is the twice of the time taken to reach the maximum height. So the time taken from this point to this point is the time taken from this point to return to this point. So we have 2u sine theta upon g. Also, to find the range, which is the horizontal distance, the range is u squared sine 2 theta over g, so that the height is equal to u squared sine squared theta upon 2g. Okay, let me teach you how I memorize this formula. Okay, let me get rid of this space. Okay, of course I know that we have small t, then big T, then R, and then H. So it's all starts from T, small t. Okay, so I just need to know that T is u sine theta upon g, and then big T, of course, from the concept, it is the twice of the small t. So I have 2u sine theta upon g, and then for the range I begin to play with the 2. So if you to play with the 2, then it has to go up here, it goes up here, and then it comes down to theta, then we have upon g, and then later this same 2 goes up again, so that we have u squared. This is already constant, is already up, so 2 goes up again, so we have 2 squared theta, then it comes down to g. So this is the formula. That's the way I memorize the formula, but you can also learn how to derive the formula. For the range to be maximum, that is, for you to have the maximum range, that is to have the farthest through, that is a kind of through that it will be no other through will go as far as that. You need to shoot the object at a particular angle, which is 45 degrees. If you shoot at 45 degrees, the object will go farther than any other angle of throw. So in this case, the r will be equal to the r max will be equal to u squared sine 2 then 45 degrees, so which is g. Notice that 2 times 45 is 90, then sine 90 degrees is 1, so that the formula to find the maximum range is equal to u squared upon g. So this is the formula to find the maximum range. A ball is kicked with an initial velocity of 20 meters per second at an angle of 30 degrees to the vertical. Find the vertical component of the velocity, time taken to reach the maximum height, total time of flight, horizontal distance covered. If another ball of equal mass is kicked with the same velocity at an angle of 45 degrees to the horizontal, find the distance at which the second ball covers more horizontal distance than the first. Now let's say let's have something of this nature. This is the ground, and then this is the vertical axis. So this is the launching velocity, which is the u, and it has the angle should be, in this case, the 30 degrees angle. Notice that the 30 degrees angle is to the vertical, so we have 30 degrees angle from the vertical axis, which is 30 degrees. But notice that the angle that we have, the angle that is required to be used in the formulas derived is the angle theta towards the horizontal axis. So we get to find that's 90 minus 30 degrees, which is equals to 60 degrees. So the theta in this case is 60 degrees. All right, so the object moves from this point and then back to this point. So the question says find the vertical component of the velocity. So the vertical component of the velocity, that's supposed to be uy, which is u sine theta. Now u in this case is 20, then theta in this case is 60 degrees. All right, so that we have 20 sine 60. 20 sine 60 is 10 root 3, which is the same thing as 17.32. All right, vertical component of the velocity. You may also find the horizontal component, which is ux equals to u cos theta. Now, time taken to reach the maximum height, the time required to get to this point, that is small letter t, which is equal to u sine theta upon g, where u is 20 and then the sine of angle 60 degrees upon g, and then g, let's use 10, so that we'll have 2 sine 60 degrees, the twice of sine of 60, which is root 3, and that's 1.732 seconds. All right, we may also find the total time of flight. Notice that the total time of flight is the twice, so we multiply this by 2, which is equal to 3.46 seconds. All right, now the horizontal distance covered, is the range. Notice that the range is that u squared sine 2 theta upon g. All right, where u is 20 squared, that's 400. The sine of 2 theta is 60 degrees, so 2 theta, that's 120 degrees upon g, which is 10, so that's equal to 40 sine 120. 40 sine 120 is equal to 20 root 3, which is equal to 34.64, and that's in meters. Okay, now the other question says if another ball of equal mass is kicked with the same velocity, let's say another ball of equal mass is kicked with the same velocity but at an angle of 45 degrees, so the object will move farther than the former object. Okay, at an angle of 45 degrees. All right, okay, find the distance at which the second ball covers more horizontal distance than the first. To find the distance at which we are actually looking for the horizontal distance, which is the range, in this case theta is now 45 degrees, so that's supposed to be the r max. Theta at 45 degrees, the maximum range, so that's supposed to be u squared sine 2 times 45 upon g, which is u squared at the same velocity. We are considering it as at the same velocity, so the initial velocity u remains 20 meter per second, so 20 squared, that's 400. Then the sine of 90 degrees, is 1, so we get to have 400 upon 10, which is equal to 40 meters. So the object which we move 40 meters because it is at angle 45 degrees. So the distance at which the second object covers more distance than the first will now become, that will be the difference between the two distances. So the r max, that is the r at 45 degrees. So we can just say the range at 45 degrees minus the range at 60 degrees. That will be equal to 40 meters minus 34.64 meters, and that will be equal to, that's equal to 5.36 meters. So 5.36 meter is the distance at which the second ball covers more horizontal distance than the first.